See if we can get there. All right, so let's take the first example with some pretty easy functions. Here's our first function, f of x, same thing as y, equals 3x minus 4, and then g of x is equal to negative 2x plus 5. And we're going to do some function operations with that. That means addition, subtraction, multiplication, division, and then there's a one we call composition that we'll get to later today, hopefully. If not, we'll get to it tomorrow. So function operations. So the first thing that we would be asked to do would be find each operations and state the domain. And let's make sure that they ask for the, no, they don't ask for the range. So state the domain. Okay, so we're going to work out the operation, addition, subtraction, whatever, and then we're going to tell them what the domain of that is. So one of the things that we need to know is what's the domain of the original problem. And things that bring up red flags for x values are, like I said earlier, with the square root or anything with like a 1/4 power or something like that, where the denominator of the rational exponent's even. Then we can't have negative numbers. We could have 0, but we couldn't have negative numbers, so that comes into play. And then if we had an x in the denominator, that's where we could have some problems with the x values. Because what's the only number we cannot divide by? 0. That's the only number that we can't divide by. So if that happens, and it will on the division more likely most every time when we do division of functions, it's going to cause us some problems. So let's look at the first operation, real simple one, f plus g of x, addition. Okay, so this is really easy. If we're going to add things together, what things do we put together? Like terms. That's what we're going to put together. So we're going to combine like terms. So if I'm adding 3x plus or minus 4 plus negative 2x plus 5, and I'm just putting them in parentheses here to show that it's two separate functions. Those parentheses aren't going to do anything with this problem because we're not, there's nothing in front of them. Okay. I'm going to add the like terms together for that particular problem. So 3x plus negative 2x would be 1x or just plain x, and then negative 4 plus 5 would be 1. So f plus g of x is equal to x plus 1. Real easy. Okay, the domain on that, since there's no square root, there's no 1/4 power, there's nothing going on here but just plain x and a 1. There are no restrictions on the x, so our domain would be all real numbers. All real numbers. That's the domain. If there's no square root, if there's no 4th root, 6th root, that sort of thing, it's all real numbers. You need to remember that. That's going to be handy this course and college algebra. Let's do subtraction. Setup is exactly the same. We're just subtracting. Now the parentheses do matter on this, because I'm subtracting that entire function there. So I've got 3x minus negative 2x, which becomes 5x, right? Because minus a negative turns positive, so that's 5x. And then we have negative 4 minus 5, which would be negative 9. So the subtraction of those two functions is that the domain of those. Are there any red flags? No square roots, no 1/4 powers or any even indexed roots. No x's in the denominator, so the domain would be all real numbers again. Okay. Addition and subtraction is pretty easy. Let's do multiplication. F times g of x. 3x minus 4 times negative 2x plus 5. Well, that's polynomial multiplication. That's something we've done before, okay? 3x times negative 2 would be negative 6x squared, 15x, positive 8x, negative 20. I can simplify that, right? Negative 6x squared plus 23x minus 20. So that's f times g of x. The domain on that one, are there any square roots or fraction exponents that we need to worry about? No, there's a squared on there, but squared doesn't change it. You know, it doesn't do anything to not work out. We can square a negative number. It works, that sort of thing. So the domain on this one would be all real numbers. Now, last operation, just regular operation, is division. F divided by g of x. 3x minus 4 over negative 2x plus 5. There's nothing to do. That's done. Now, the domain is where there's something to do. Because there's a red flag on this one because we have what in the denominator? A variable, and that's a problem. We can't have a variable in the denominator. So what we've got to do is decide, okay, what's going to make that 0 in the denominator? So we just set negative 2x plus 5 equal to 0 and solve that. Negative 2x equals negative 5, and then that'd be negative, x is equal to positive 5 over 2. What that does to the domain for this problem is that tells you what x can't be. And that's all you've got to tell me, is that x cannot equal 5 over 2. Because that's the number that would mess up this problem. Because if it was 5 over 2 and I plugged it in here, I'd end up with a 0 in the bottom. I'd end up with something else up top, but in the bottom I'd get 0, and I cannot divide by 0. So that's where that red flag is coming from. Anytime there's a variable in the denominator. All right. So that's dealing with regular functions. Let's get into what we've been dealing with the rational exponent functions and things. Okay. Example B. All right, so f of x, we'll kind of ease our way into this. We'll make it just plain old 6x. 6 times x to the first power, and then g of x, let's make it x to the 3/4. Before we get started, let's discuss the domain of each of those, because this is a little bit different because the x to the 3/4. 6x, are there any red flags on that function? So what's the domain of that of f? All real numbers, right? And then on this other one, it's got a 3/4 exponent, which is an even root. It's like the fourth root. What kind of numbers can we not take an even root of? Negative numbers. So the domain, all right, so the domain of this one, y'all said, was all reals. All real numbers. And then this one, the domain, is x has got to be greater than or equal to 0. Okay. Because that's a positive answer, right? We can take the square root or the fourth root of 0. It's just 0. But we can't do negative numbers because that's where the complex number system gets involved. And we're trying not to worry about those in this particular chapter. Okay. So let's do some function operations with this, and you'll see that it's not really that bad. It's pretty easy, especially with the addition and subtraction, because in order to add and subtract, you have to have what kind of things? You got to have like terms. Are these like terms? This is plain x, that's x to the 3/4. They're not like terms. There's nothing you can do to make them like terms. That's the answer. The domain is the most restrictive one. Which one of those pieces is restricted the most? X to the 3/4, right? It's the only one that had a restriction on it, right? So the domain of this addition function is going to be the domain of the x to the 3/4 function, which would be x is greater than or equal to 0. It's kind of like if you're ever been to like a company picnic or something with your parents, and they do like the three-legged race, where they tie you, or y'all ever done that anyway, where they tie you together and you've got to go run the race. You can only go as fast as your partner, right? So the domain on these can only go where the slowest one is, and the x to the 3/4 is like the slowest person. Okay, so you can't go faster than your slowest person if you're running like a team race, and that's what we're thinking here. Is that if we're running a team race, our slowest person is the one that's going to set our time really out of that. I mean, all our athletes, y'all ever did the Indian run? If you play soccer, you've done that. If you play baseball, you've done that too. Where what you do is you get in a line, and whoever's in front sets the pace, and then whoever's in back has to sprint around them once you reach a certain spot and get in the front. And then, I don't know, you may not call it the Indian run anymore. Yeah, and then once they get there, you run a lap at their pace, and then the last person last in line has to sprint to the front and that sort of thing. So you don't want to set the pace too high at the beginning. You want to set the pace where your slowest person or your person with the most restrictions can still make it around out of that. So we're setting our domain to where the one with the most restrictions still works. That's what we're doing here. I guess I could use the analogy of computers, that you can have the fastest processor in the world, but if the motherboard won't support that speed, the motherboard sets the speed. So subtraction, same idea. 6x minus x to the 3/4. Are those like terms? No. So you can't put them together. What's the domain? Same thing. Nothing changed there. You'll see that the addition and subtraction, the domains should be the same every time. I mean, they're going to be the same. Now let's look at the multiplication. F times G. Now, do you have to be like terms in order to multiply? No. You can multiply 6x times x to the 3/4. And this is where section 6.2 comes in, knowing your exponent rules. What's the rule when I multiply 6x times x to the 3/4? I do what with the exponents? I add them because I'm multiplying, right? 1 plus 3/4 would be 1 3/4, which is 4 plus 7 over 4. So there's my multiplication function. The domain of that guess what that is? That's got a even index on it. It's an even denominator in the fractional exponent. So that's going to tell us that it's got to be positive numbers. So that's what we're going to have. X is greater than or equal to 0. It just happens to be the same. Won't always be the same as addition and subtraction. We'll see that with the division, that it can change stuff there. Okay. Let's look at the division. F, change colors. F divided by G of X. So we got 6x over x to the 3/4. Can that be simplified using our exponent rules that we learned, hopefully, in the last two sections? X to the 1/4, because what rule are you using, Zach? Well, but what's the rule when you're dividing? Subtract. 1 minus 3/4 would be 6x to the 1/4. 1 minus 3/4 is positive 1/4. So we have 6x to the 1/4. We don't have to move anything around because it's a positive answer. If it would have been negative 1/4, we'd say, oh, well, that's got to go to the bottom and to work. And then we would have to deal with the fraction exponent in the denominator. But that one, works out nice. And then that would give us a domain of x. I'm going to throw you for a loop here. I take the equal sign off of that. Why did I take the equal sign off of that? What does it mean that I took the equal sign off of it? That x can't be 0. Where is the place that x can't be 0 at? The bottom. Where did this answer come from? It came from there, where we had put an x in the bottom. So that's why. When you look at your domain, you got to think, where did it come from? Okay? So it came from simplifying this. So you want to look at your unsimplified part first to decide if you need to do anything with that. Okay? And then the simplified version gets you the greater than part. Anyway, so we got to drop the 0, so no equal to mark on that one. For that. Let's look at same two functions. Let's do g divided by f. So all that does is just flip it over, right? X to the 3/4 over 6x. But if I follow the rules for division, 3/4 minus 1 would be negative 1/4. But remember, we can't have negative exponents, so let's fix that. Oh, man. Well, that created another problem. I can't have an x in the denominator. So what do I multiply to get rid of the x in the denominator? Or the x to the fraction exponent in the denominator? Good job. X to the 3/4. And that's going to give us 6x to the 3/4 over x, which is the simplified version of that. Which is weird that the 6 moved out of that, but it does. Hold on. Back up. That's 1/6. Sorry. There we go. Now then, the 6 doesn't move. The negative 1/4, it's kind of going to the top. The answer to that division part. 3/4 minus 1 is x to the negative 1/4. This is like, there's an understood 1 in front of the x to the 3/4. So that's where this 1/6 is coming from. And then we go down here, and technically there's a 1 up there. And I'm multiplying by x to the 3/4 to turn this into x to the first. Remember, we want to get that to be a whole number. So I need to multiply it by 3/4. Add 3/4 to 1/4 to get 1. And then top part, 1 times that is that. 6 times x on the bottom. And we've gotten there. Now, what does that do to the domain of that? The same thing it did on the f divided by g. We have to drop the x being 0 because got an x in the denominator, so x can't be 0. So there goes the equal to mark. But then we have a fraction exponent with an even number in the bottom, so that's why we got to have greater than 0, positive numbers out of that. Okay. Let's try another one. Let's get one that's got two functions that are like what we've done the last couple of days. F of x is equal to negative 2, x to the 2/3, and then g of x is 7, x to the 2/3. Now this one, again, you want to think, what's the domain of each one of those before you start? It's not going to be one of the questions. It's just going to be what you need to help you as you go. So On this one, are there any restrictions? I got a fraction exponent, but the denominator is what kind of number? Well, the bottom is not, it's an odd number. It's not a negative number, it's an odd number. The denominator there is 3. It's an odd number. Can we take the cubed root of a negative number? Cube root of negative 27 is negative 3. So yes, you can take the cube root of negatives. You can't take the even root of negatives. So the denominator on the fraction exponent tells you whether or not you got to do the greater than or equal to 0 thing. Okay. So since that's odd, we don't have to worry about that. The domain of that one and consequently that one are both all real numbers. So that's the domain. And that domain of this one's the same. Because it's an odd number in the denominator of the exponent. If it's an even number, you got to have positive answers, positive x values. If it's an odd number, it doesn't matter. Because you can take the cubed root of a negative number. You can take the 5th root of a negative number. You can take the 7th root of a negative number. You can take the 81st root of a negative number. Not that you ever would, but you could. All right. Let's do the operations here. Let's start with the addition. Are these two like terms? Are they like terms? Yeah, they both have x to the 2/3. So we combine those, and negative 2 plus 7 would be positive 5 x to the 2/3. The domain would be all real numbers again. Yeah, it does sound terrible. Gosh. I guess. Subtraction. Negative 2x to the 2/3 minus 7x to the 2/3. That'll simplify to be what? Negative 9x to the 2/3. What's the domain of that one? All real numbers. Let's do the multiplication. F times G. X. Negative 2x to the 2/3 times 7x to the 2/3. So it'd be negative 14 x to the what? 4/9. Is it 4/9? Are we sure? I think so. I'm multiplying, and those are exponents. 4/3. Because the rule is when you multiply, you do what with exponents? You add them. So that's 4/3, not 4/9. Yes, ma'am. Yeah, absolutely. Kylie said when you're adding and subtracting, you just leave the exponents alone. Yeah, absolutely. That's always that's going to be the case. True. Good observation. All right, so that has a domain of all real numbers again. Nothing's really changed there. Let's do the division. Negative 2x to the 2/3 over 7x to the 2/3. What happens? Subtract your exponents. I heard somebody whisper that. That's right. 2/3 minus 2/3 is 0. So are there any x's left? No. It's just a fraction, -2/7. Here's where everybody misses this problem. What's the domain of that? Kylie? 2/3 minus 2/3 is 0. X to the 0 power, which is 1. So they're canceling each other out. So that's why it's -2/7. Not less than 0, but not just greater than 0. X can't be 0. Because up here, there's an x in the denominator. That's where that came from. And that's one of the most commonly missed domains there, is that when it simplifies and gets rid of the x's in the denominator, it still has that restriction on the domain that x is not 0. Because we have an x in the denominator. Anytime there's an x in the denominator, the only x value that would make the denominator equal to 0 is 0. So that's where that's coming from. Is setting that denominator equal to 0. Okay. All right. Let's look at function composition real quick. These are not bad actually at all. Function composition. And you'll get some time in class tomorrow to work. Y'all understand that, don't you? Yeah. I'm going to give you some time tomorrow to work on this. Function composition. What that means, and I'll introduce the notation that college algebra uses that we don't necessarily use in here, but the composition is, it looks like a letter O, but it's not on the notebook paper line. It's a little bit above it. It's just a little small circle in the middle. And it looks like the word fog, but it's f composed with g of x. What that means is you take the g of x function and put it in for x in the f of x function. All right, we're going to do an example and you'll see what I mean. I don't know what letter we're on. D. All right, so let's look at these. This function, f of x is equal to 6x plus 8, and g of x is equal to -2x plus 10. F composed with g of x, and this is the notation your book's going to use is this. What that means is you're going to take this g of x, what it's equal to, and replace x in that function. That's all that means. Fancy words, math terms for meaning put that in for x and simplify it. Okay, so we would take 6 parentheses -2x plus 10, close the parentheses, plus 8. So we've replaced in the f of x function, whatever's listed first or on the outside, its x gets replaced by the other function. Anywhere there's an x in the problem, if there's more than one. So that'd be -12x plus 60 plus 8, which would be -12x plus 68. By just distributing 6 to both of those and then simplifying. By replacing x in the f of x function with what g of x is equal to. So it's kind of like substitution when you're solving systems of equations back in Algebra 1, Chapter 7 stuff of that particular class. So if you had year-long Algebra 1, it was in the fall of that year. Or it should have been in the fall. If you had me for class, it was in the fall. If you go the other direction and do g composed with f, that just means you're taking the f of x function and putting it inside of the g of x function. So where the x was in the g of x function, it's right beside the negative 2. We're going to put, instead of x, we're going to put 6x plus 8. And then the plus 10 is hanging out on the outside. And we're going to simplify that. Get a different answer, negative 12x minus 6. That's the g of f of x. All right. Got it. Yeah, if you did domain on these, what's the domain of each of these? Y. That's right, but why? What are the red flags for domain? Exponents that have a even denominator, variables in the denominator. Are there any of those in these problems? No, so that's why it's all real numbers. None of those red flags come up in this problem. Let's look at one that does. Here's our f of x function, 4x to the negative 1, and then our g of x function is 5x minus 2. Now, your book doesn't teach it this way, but my advice to you is fix negative exponents before you even start, because it makes it easier. There's a negative exponent. What can I do to make it not negative? 4 over x. Yeah, so this is really 4 over x. That's what that function says. It's just written with exponents instead of not exponents. Okay? Now, what does that do to the domain of this function, the f function? X can't be 0. So there's a restriction on that domain. Is there a restriction on this one? No, there's not any red flags. There's no x in the denominator. There's no fraction exponents with an even denominator. So that one has a domain all real numbers. Okay, so let's do the function composition. Let's go f composed with g of x. So that means you're taking the g of x function and replacing x with it. So I'm going to write it 4 over 5x minus 2. I can't simplify that because there's nothing in the numerator and the denominator that works together. But I can find the domain of that. Where's the red flag for the domain? X is in the denominator. What's going to make the denominator a 0? Here's how you find it. Set the denominator equal to 0 and solve it. So that's 5x is equal to 2, divide by 5, get x. If x were 2/5, we'd get a 0 in the denominator. So x cannot be 2/5 is the domain for that one. Okay. All right, let's go the other direction. Let's do g composed with f. G composed with f. So that means you're taking the f of x function, 4 over x, and plugging it into the g of x function. So we would have 5 parentheses, 4 over x, close parentheses, minus 2. Doesn't really make it look better, but it is simplifying of some sort. We can multiply 5, technically 5 over 1 times 4 over x, and get what? Yeah, 20 over x. Doesn't really help things any at all, but it does get us, something that looks a little bit better than that. And that's simplified. There's nothing else you could do. What's the domain for that? Yeah, x just can't be 0 because the only denominator here is just plain x. So x being 0 would be what messes that up. All right, if you want to look at some of these this evening, you can. You got about 5 minutes left in class. On page 432. Numbers 3 through 35. Odd ones be fun. Numbers 3 through 9, it asks you to, it's addition and subtraction. You're not doing all of the operations with every single problem. So 3 through 9, do the operation they're asking you to do. 13 through 17, do the operation they're asking you to do, multiplication or division. And then 21 through 27, you got a couple of different functions, 3 different functions there. And they're wanting you to find the indicated value, look at composition, what that means for that. And then 29 through 35, again, it's composition like what our example showed. And so homework from last night, if y'all could get that to me today, that'd be awesome if you got it done. If you don't, get it to me as soon as you can. 2 pages. Okay.
Like super sure.
Do what?
You don't like super sure?
What's that?
This one's much easier than the last one.
It's the same. Oh, really? Yeah, it's the same skill. Much
Well, I
different.
guess I must understand it better or something.
Well, it's not quite as robust, I guess. There's not as many different kinds of problems as there was yesterday. But when we get into the rest of the chapter we're solving, there, get back to some of that stuff. So it gets a little bit more complicated.
I got some missing work.
Does that mean, okay. You got the page numbers? All right, awesome. I'll get it right.
This is the one you gave us yesterday, right?
424?
Yeah.
Yeah, that's what it says. And if you got anything else, you can bring that to me too. How many of you guys have English this term? Junior? 1, 2, 3, 4. Okay. 5. And McKenna does too? Okay, 6, 7. All right. I don't know for sure. We haven't got a schedule yet on testing and stuff, but I know that some of the end of course testing starts the week after we get back from Thanksgiving. And it's English is the part that would start that week. There's like a writing portion that you have to do that used to be done at a different time of the year, and they're just doing it now in that. I think that's what I've heard. Like I said, we haven't got an official schedule yet, but I think that's what's going to happen. Is they'll do the writing portion like that Thursday or Friday, and then you'll do the regular one the next week sometime, like the multiple choice version type thing. I think that's right.